Hi everyone, my name is Matt, and I'm working on this project called Plotly. We're building
There we go.
Yeah.
We're building a web-based platform for making graphs and analyzing data. And I figured I'd start off just by walking through this blog post that I've been working on this week that shows remakes of a bunch of famous graphs. The point behind a lot of what we're trying to do is make it so working out of your own environments like Python or R and ggplot and MATLAB, you can get cloud-based performance and interaction and sharing and collaboration. So do folks in here use GitHub? Cool. So we have basically tried to mentally think about it because we all love GitHub, and we are trying to do basically for graphing and for data what we have used GitHub for collaboration on coding. Quick benchmarking exercise. I know there was another discussion. How many people in here use ggplot for their plotting? Python, MATLAB, Excel. Other things that I'm missing? Tableau, cool.
D3.
Other stuff?
Prism.
Cool. Alright, cool, thank you. Alright, so we have figure converters for those languages, so for each of those, I will discuss those in a few moments. So this is the first plot. Have folks in here heard of Anscombe's quartet? It's this really cool data set that this guy made that has extremely similar statistical properties. So it's the same linear regression coefficients, XY means, XY variance. And if you look at it here, you can see it looks pretty similar. But then if you actually plot it, it looks quite different. But the painful thing about most plots, and a thing that drove us to want to get started on Plotly, is that it's really frustrating to not be able to have graphs that are interactive out of the box. And that's kind of what D3 is really cool for, this JavaScript library that we use to render plots. And it's really painful when you have to make a plot and then kind of email it around and be like, so I worked at Facebook before this, and whenever I would work with people, we'd do this thing where I'd pull data out of our database and then analyze it locally and then make some graphs and then email out these extremely large emails that would have a bunch of code and descriptions and keys and links and pictures and screenshots, and someone would be like, oh, would you mind changing the color on this line? And I'd be like, yeah, let me email you back in 4 hours. And so the point behind Plotly is to make it so once you've made a graph, you can just embed it in iframes. So I made this one originally with ggplot2, and then just converted it into Plotly. I'll show how that works in a second. And then once you have a new graph, you can always just stick it inside of an iframe and just embed it anywhere. So with Shiny or with Knitter, and so you can just plot right from your respective environments, and then every plot gets its own URL, and the data from every plot always stays with the plot, and you can make GET requests for that from any language. And then we translate the plot into a JSON object that then we translate into any other language. So I originally made that plot with ggplot2, but if you work with someone on your team who wants to edit with Python or with MATLAB or with R or something like that, then you can collaborate with them too. But if you work with people who don't code, or you don't want to spend 4 hours figuring out how to move the annotations on your plots, then we have a GUI that lets you edit everything about the figure. So traces, styles, error bars, everything. It's all just kind of like a wrapper on top of D3, which is this JavaScript visualization library that the New York Times uses. And then the data just sits underneath everything, and so you can edit it in a grid, and when you share plots, then you get to share the whole figure object. And so it becomes like a reproducible version of what you're working on. Yeah?
Sorry to interrupt. Once you print the plot, can you go back to the data and edit it so that the plot alters? I've been having pretty difficulty with that.
Yeah, so you can, you can run so for any we've tried to make it so you can kind of like always append or extend traces. So like if you have a new trace that you want to draw onto a pre-existing plot, you just like pick that plot and drop new data onto it. And then like the collaboration aspect, it works just like, we also have these themes that we have used. I tried to get them to be called Instagraph, but that didn't stick. And then we have like fitting families, so this is why, so the reason I'm in San Francisco, or San Diego, sorry, I live in San Francisco is because we were here for the American Association of Physics Teachers annual convention, and a lot, yeah, it was fun. And so a lot of high school students and college students need to use like histograms and box plots and other scientific plots that you can't get from most software that you have to pay for. And so it's cool because like all of Plotly is free. So we do enterprise installations. We ship Plotly in a Docker instance so people can run it locally. So we have instances at like Google and SpaceX and stuff like that, which means we just get to give it away for free for unlimited public use. So there's no downloads, no installations. It's just like GitHub in that regard, and so it all just like runs online. And then for sharing, I can just be like, you know, I've like made a plot here. I want to like add a collaborator, like autofilling. But yeah, so you can just collaborate from here and then set things to public or private. So that's kind of like the overall part of it, and now I will go back to the original thing I was starting with. So have folks seen this chart before? William Playfair. If you've read Tufte, you've probably seen a lot of these charts. That's where this mostly came from. So this guy invented the line chart and the bar chart and the pie graph and circle graph, and this is one of his famous ones. And so you know, it's pretty cool, but it's pretty wild when you think about it, you know, because it's like this is a funny thing here where the bottom here he says like the line is divided into years, and if someone wrote that on like a line chart now that had decades on it, you'd be like, who's this crazy person who thinks that I don't understand what years are? But if you invented the graph and like no one had ever looked at one before, you'd have to put a lot more on it to tell them what's going on. But like the great thing now is like we can do things like text on the hover that mean we don't have to put on nearly as much stuff because it's all just like holds the data behind it. And you know, just kind of like take off some of the axis labels. So that's been a fun one to redo. Then have folks seen this one? Frances Nightingale. So this shows a variety of causes of mortality. She made it in like the 1860s. But like pie charts, it can be a little hard to see data if it's not side by side. So like that's kind of like the thing that always confuses me about pie charts is you don't ever really know how much, like what the quantities are unless someone drops an annotation on it because you can't do a side by side comparison of it. But another thing that like hover text lets you do that's cool is I can actually see the traces that go with it and be able to make an inline comparison as I'm looking at it. But another way to visualize that exact same data is we can just do it as a stacked bar chart. And that lets us do a real side-by-side comparison for it. Is it cool if I pull this tack out of here?
Go for it.
Yeah.
I was holding our place for something very important.
Sorry. So we can do like a side-by-side comparison. And the fun thing here is you can see, so like along the bottom, I'm sure that folks in here do lots of graphing. You're familiar with the great travesty that is dealing with datetime objects. We read 400 different datetime stamps, and it's just like there's always some new one that comes in. But so handling them is pretty fun though, because like if I zoom in here, you'll see like right now it's just delineated by year. But if I zoom in, Plotly gives me then a redraw that shows the months, and then per month, and then if you keep going, if you have like data that goes down to like seconds, you can just like keep, as you zoom in, it'll just keep redrawing the graph. And then you can also throw a little spark line in here, and that actually shows the exact same data, just as an inset plot right there. And so you could even zoom in on that if you wanted to. And then I've gotten really into making GIFs recently. So this is a GIF that shows how to make this. If you are into making GIFs, there's this awesome tool called GIF Brewery that lets you make a QuickTime video of a screencast, and then you can just convert it into a GIF. It's really cool.
That's handy.
Have folks in here seen this graph?
Yeah.
So this is the classic. So if you haven't seen it, this is this famous visualization that shows the decimation of Napoleon's army size as he was going on this march. So there's a lot going on here. So this one, the tan one here, shows the size of the army on the advance to Moscow from Poland, and the black line across the bottom shows troop size on the way back. And the line is actually sized for the number of troops that are in the army during the advance. So it goes from like 422,000 to like the ultimate size is 10,000. So it's actually spaced for the number of troops that are in it. And then the axes also show distance. And then across the bottom here, this one is temperature. And so it's a pretty gnarly graph because it has like just an incredible density of data in it. But it's really hard to read if you don't know what it means. And it can be a little confusing. So we can do like a remake of it with Plotly that kind of shows us like what's going on here, and we can get, you know, interactivity and stuff like that out of it. Or we can take the data and redraw it as our own version of it. So this is that same data set, showing all of the same data here. So across from our first y-axis, we're showing troop levels. Moscow is where the retreat starts. Each of the stars along the bottom represent prominent city numbers, and the second y-axis shows temperature as starting at the retreat, which is also where temperature starts on the first plot. And then across the bottom, we have two x-axes, the first one that shows date, and the second one that shows distance traveled. And so the data is just overlaid on top of both of them. And we made this plot without a line of code. Yeah.
Can you refresh my memory and what does it mean when that bar tacks?
Bar attacks.
When it tacks, when it changes direction a little bit on
Which
the
one?
original graph.
Oh, it's split. They had a part of the army went to a different city than the main army.
Oh, there's a lot of different small changes in direction.
Yeah, so we didn't try and get that in there because it's actually like it's geographic data that's underlying it.
Yeah.
Latin long.
Yeah. So it's lat long drawn underneath it. So we didn't go for trying to replicate all of that. Next one is have folks seen this one? So this is this Jon Snow map. And so this is a pretty interesting story. So this guy was a doctor, and he made this map, and even though when he measured or he studied the water that was at, because there was all these outbreaks of cholera, yeah. He, even when he studied the water, he wasn't able to find anything that was actually wrong with the water itself. He, by looking at the number of deaths that were clustered around particular pumps, was able to see that there were an incredible number of pumps in proximity to one pump, or deaths in proximity to one pump, this pump on Broad Street. And so each of the little bars here represents the deaths that happened in proximity to the Broad Street pump. And so in making that case, he was able to convince the local town council to shut that pump down. They still have that pump there today. And so this is a remake with ggplot2. So I took our ggplot figure converter and I turned off hover text, and so each of the stars is a pump, and then each of the red dots is a death. They have an opacity setting to them, so as the red dots get darker, that's where more people have died. And so if we want to zoom in, then we can zoom in and keep getting new data each time we zoom in to be able to see where each death happened in relevance to the streets. Another GIF. Or we can do another version of it. So this one shows polygons drawn on top of the same map. And so the polygons are basically kind of like a nearest pump test. So which pump would you go to if you just walked to the closest pump in proximity to where you lived? And so we can then see that if you do this, there's only like one person who would walk to this pump. And there are, a couple more who would walk to this pump. But tons of people would walk to the Broad Street pump. And even in these like close clusters here, you could easily see people who live like there, or there, or there, like breaking to the Broad Street pump anyways. Or maybe they, share water with their neighbors or something like that. And then we have, but like the problem there though is, so you can't still see, like, though it shows, this is a nice way of showing like overall density, it doesn't still show us like the data itself. So I have a little inset bar chart here that shows calculations for the number of deaths per region. So Broad Street, 334, the pink region is 60, and then the next one over is 59. And I'm currently in the midst of investigating the names of those neighborhoods and streets because I don't know London at all. So I'm gonna put like custom hover text on it to show like the name of each pump in relationship to where it is. Yeah.
Sorry, what are the colors of the polygons?
I didn't understand.
Some are the colors. Some are pink. Some are blue.
Oh yeah, the colors are blended for. There's like a color bar that went with it, but I silenced that.
So they don't mean anything?
Not anymore.
Okay.
Then this is the Hans Rosling Gapminder chart. So this is a pretty cool bubble chart here. And so it shows 4 degrees of data about each data point, which is pretty fun because on the bottom here we're showing gross national product per country, and it's a log axis. And then on the y-axis, which is also a log axis, we're showing life expectancy. And then each of the bubbles represents a country, and each of the bubbles' sizes represents the population of that country. And then the color represents a continent-based clustering for them. And so then it's cool because like we can actually see, like if you couldn't see hover text on this, there would be no way to really like understand the specifics of things that are going on, especially if I want to know like what's going on in here. But it's cool though because I can just kind of like zoom in and see actual data on the hover for each of the countries that I'm interested in seeing, and kind of like move around and do some exploration with it. And you can see that, and so for like France, you can see all of the data and like the precise data that's actually in the hover. So this is one that we made using Python and pulling data from a MySQL database. We have a live streaming capacity. So this is how you can stream this into a notebook. If you want to stream inside of IPython notebooks, you can. We have kind of like 2 ways of streaming. One is in this way. Well, there's really 3 ways of streaming. One is in this way. So this is a simulation of the double pendulum. It was made inside of an IPython notebook. And this is kind of like an animation. So this one's running with a while true loop on it. So this is kind of like an infinite spin. And we have another one that does. So this is kind of useful for like if you want to do like animations or something like that. So this is the Lorenz attractor, and so we have like a 3D simulation of it running here that we can kind of like zoom in and see what's actually going on as it's streaming. So you can stream like that. You can also stream just like live WebSocket data and push it in every 50 milliseconds. So if you have like something that you want to push from, or you can just kind of like post, like run a cron job and periodically repost new data like every minute or every day or something like that. This is the Arduino and Raspberry Pi example. So this is Plotly's first ever streaming graph that anyone made this. So this guy who actually lives I think he lives in San Diego, he's in SoCal, streams and controls the temperature in his house using a set of calls from Arduinos and Raspberry Pis and a couple of APIs and blends them all onto the same plot and shows like a live stream, right? Like we can see this is like, running his temperature in here. And then we have like humidity and cloud cover with it, and then pressure with it. And he has like some calculation that he's running on it where he activates his fan in his apartment when it gets to a certain it's pretty cool.
Extreme.
Yeah, I think if you want to check this one out too, it's like he posted all of his code here. Yeah, he's running it out of MySQL.
God.
And then, you know, when you think about it, like maps are kind of like the oldest type of graph in a lot of ways. So I recently watched Interstellar twice, and also read Kip Thorne's exceptional book, The Science Behind Interstellar, which I highly recommend. And he showed all these maps in here, and it's pretty cool and kind of wild because like this is, you know, what we knew of the Earth in 1507. This is what we knew of the Earth in 1570, you know, and it's kind of like wild to see where it's like South America doesn't seem to look like that now. 1744, and then this guy on our team made this graph with MATLAB that's pretty cool, where we can see, so you can see like body of water data here. We can like zoom out and toggle and spin and flip on it and zoom in, and then we can actually just go right inside the Earth here and just look at it from the outside here. So that's the blog post that I'm working on this week, and some of my favorite graphs. At this point, I will pause and see if anyone has. Oh yeah. Oh, also, here's some more fun 3D graphs that I made into GIFs this week. So this is a fun one. So you can do like you can do like splits. Huh?
MATLAB, right? Yeah.
This one was with Python. So this is a 3D Gaussian, and the contour lines on the side are really fun. I've turned off the tick labels here. We're gonna have hover text for 3D soon. So it's cool because you can set some like serious opacity on this and then actually see the contour lines getting drawn on the side. These two I made with ggplot. So this one shows this is from Stat Contour. And so it's the 3D volcano data. And then it's kind of cool because you can see like the lines get drawn on the side as you look at it. And then this is also, I think, from Stat Contour. So these were both ones that I made with ggplot too, and then converted into Plotly.
Can you do 3D with ggplot too?
No. So the way that I did this was just setting, here I have, I can show. So the way that one was done was I used ggplot to make, and then Plotly's figure converter to turn a plot that I made with geom_tile into Plotly. So this is the function I called Plotly, and then drew it here, and then I can go into Plotly's interface and change plot types to turn it into a 3D plot. And then I made the other 3D plot that you see in there was made with ggplot and used the same thing. And then I used Python to drop them onto the same like multifaceted 3D plot together. I will briefly, because I have referenced it so many times, show you how the figure converter works. Oh, perfect. We have something ready. Alright, so we call ggplot and we make a plot. And then we call Plotly, and that's our figure converter for ggplot. And this calls Plotly and then redraws the plot here at this URL. And so I can set that to public or private if I want to. And then I have my box plot here. Then I can go in, and it's kind of fun then because you can then get like all the GUI based interaction around it that I want to. So, you know, if I want to like change some of the stylings here, we can like show points, calculate the mean on it. Maybe, you know, we want to play with like some of our colors here. Let's see. Oh, let's apply a theme.
Instagram.
Yeah. You know, it's not that bad of an idea. So maybe set some opacity for it. Throw a little jitter in there. And then and then I can take that, and now if I wanted to, I can just share that or post that on the internet, or you can just embed that in websites or reports or Knitter docs, and then we have connections for like being able to set up that kind of like interactive back and forth if you're using Shiny. And so you can just kind of like set up, so Shiny has this cool thing where you can set up iframes that call, so it's like tags iframe. Yeah, so we can just like have a plot that's running, and it's essentially like, so it's a ggplot, and then it has Shiny as bindings with it, so you can use like Shiny to set up like interactivity on top of your ggplot interactivity that you're pushing up. So this has been kind of like an interesting and like fun thing where it's like the question someone asked a moment ago has been an interesting one for us to face, which is like, does ggplot have a 3D syntax? And no, it doesn't, in the way that like we've built 3D to be able to have like, you know, those like contour lines or lots of the other things that you can control. So that's been an interesting thing because we do the same figure conversion technique. I'm gonna close. We do the same figure conversion technique. So this is inside of an IPython notebook. If you are an R users heard of IPython notebooks? It lets you run this kind of like Mathematica like notebook style, so it's inputs and outputs. And then like, so it just like prints the output right back into the notebook, and then you can just publish the notebook. And if you're interested, Rackspace has this pretty cool new project where they have a bare metal server that lets you run notebooks online. And so this is like how it works, right? So I just like execute my notebook here, and it does like everything that I want here in the browser. And it's pretty cool because you can switch the kernels between, they don't have R up anymore, but they used to have R. But so yes, you can run R like this, because IPython has an R kernel now that lets you run just like this. And then if you want to share it, you can just download the plot, or the whole notebook session as either an IPython file, a Python file, HTML files, or PDF files, and just output it all. And then you can just share like code, data, markdown, because it supports like markdown, LaTeX, like everything like that. It's pretty cool. So this is that same routine running with Python using our matplotlib figure converter. So here we draw a matplotlib figure, and just like we invoked pyggplotly, we invoke iplotmpl, which converts the matplotlib figure into a plot that's then embedded inside of my IPython notebook. And here we can do this fun thing where I'll show an example. I think I have an example. I don't have it. Oh, that's another notebook. All right. That's a lot of what we do. Does anyone have questions, thoughts, comments? Yes.
I have a question. So,
Yes.
okay, I'm working with multiple plots or whatever, and
Or whatever.
yeah,
Or, okay.
well, yeah.
Go on.
And phone rings, I put stuff down or whatever, and the underlying code to make the plotly graph, I can export that as JSON, or does it give me the code
Yeah, so for
from a
any,
reproducibility standpoint?
yeah, so that's been a really important thing for us is we, we care a lot about reproducibility. So for any plot that we make, and I'll just show you an example here. So this is an example here. So I got this code here off of, I found this plot that was on, it was like a ggplot on the World Bank's website, and I wanted the data underneath it, but you know how this story ends. You can't get the data from plots when you see them, and you can't get the code to reproduce them. So I made the plot, I called plotly's ggplot function, and then I called plotly's Python function, embed, and embedded it. And so this is that ggplot plot drawn from plotly. And then I can edit it with Python. So then I call strip style, and that takes out any styling that's not plotly's syntax. And then I replot the data using matplotlib and turn it into subplots, or use Plotly's way of redrawing it. And for then, let's say then I went in and edited with the GUI. So for any plot that I have, no matter where it came from, if you walk away to go answer the phone, I can always just get the most up-to-date version of it, either from just going to the web URL for it, or making GET requests. So you can just call it like get fig and then print it, or just go here and just get the JSON or the Python or MATLAB to reproduce it, and then I can export it in as well. Just kind of you can like do that. You can make static call plots, or you can just like export SVG or PNG or PDF files just from here, or do that from like inside of the GUI. And then so every plot has like 11 different objects associated with it in that way, because you have all of the different strings for each of like the languages to reproduce it, plus a JSON object, because we use JSON for all of our graphing. Few things get me excited these days, like JSON. But yeah, so you can then just kind of like get that whole setup or export it as like one of the different file types, and you can do that programmatically from different languages, or because all of our APIs are just wrappers around our REST API. So like early on we made a couple decisions about like trying to maintain a pretty flexible backend. So everything that we use JSON to represent all of our graph objects, and then within that JSON dictionary, data itself is another component of our graphing dictionary, and so the data always just is nested inside of the whole JSON string that represents each plot. Does that answer your question?
Yeah, and then I'm thinking you could take that whole stuff and just like use GitHub 3.hi's API and just not have to go through the GitHub. Like you could automate the whole thing.
Mm-hmm. Yeah, I'm for that post that I'm working on. Like there are certain things that I prefer to do from the GUI and certain things that I prefer to do from the API, and so like certain things that I prefer to do from R. And so it's pretty nice because I can just kind of like I'll like go into the GUI, edit some stuff, and then export the Python file, and then go in and edit it with Python or something like that. So it's pretty nice, and it's cool because it's like that's how we pay the bills, is by kind of supporting like language agnostic interoperable collaboration, where teams that have like people who code and don't code and who use MATLAB and use Python and all of this stuff want to be able to have a way of collaborating besides email, and so they can use it as kind of like their cloud interface, because every plot that you make just sits inside of your file repository here. So I can always just go to the link for any of those, or just open it up and edit it locally here. So you can see I've been doing a lot of the same plots recently. But yeah, and then from here you can also just kind of like stick a bunch of plots in your folders. And so this is how, so we recently went through like a bunch of, so like we recently went through like a fundraising round, and we all just like, my co-founders and I just had, like we didn't do a deck, this was just like, we just made a bunch of graphs, and then we could just all edit them together, because I can put 20 or 30 graphs and data files and grids inside of one folder and just share the folder with you. And then you get 20 graphs that we can edit together, or our whole team can edit together if we want to.
So, this isn't related, maybe you've said this, but just wanted to clarify. So this is when you share a graph, you're on the Plotly server, but a company can buy their own version of this, right?
Yeah.
Okay.
Yeah, we use, have folks in here used or heard of Docker? So, would someone like to talk about Docker? You seemed like you were ready.
If you played with any kind of VM system, Docker is an abstraction on top of VMs that allows you to just wrap up the important bits of the OS that you care about, mainly your code, as opposed to everything underneath Linux. When you have a virtual machine, you deploy a Docker container on top of it, and it contains just your code, and it's kind of a repeatable, smaller way of distributing a working application without having to distribute all of Ubuntu with it. It allows you to kind of keep track of changes as it moves on. It has a lot of other very interesting and nice features.
So I run IPython inside of a Docker instance that I have, and so that Docker instance has like IPython, matplotlib, plotly, a bunch of other stuff in it, and I just called it right there from my terminal. So I just say boot Docker up, and then it calls it, and now I have like that whole VM running. And so I can run all at the same time in different Docker instances, like the R kernel for IPython, a Python kernel, and not just have like just the kernel, but run like R and like, you know, like different libraries that I'm interested in running and that kind of stuff. So it's a really convenient thing because we can just like let other companies just like they, you know, a couple bash commands and then they just rebuild all of Plotly, because we've built it also. Like our instance of Plotly that we use is Docker. So we use Docker, and then other, like when companies want to rebuild it, they just run it locally, and so they just set up their own instance, because we don't want to have to like, you know, ship like physical servers or something. And this was like, we have this guy on our team who worked for Sun, and it was like all his idea, because we were like, yeah, we'll like load Plotly onto some servers and send it to people. And this guy, Jody, he's a miracle worker, was like, no.
Wrap this in a container and ship it.
Yeah. And it's been a real game changer for us. It's extremely cool. Because it's nice, because like we use that, and then we use like HipChat for all of our collaboration. So it's like, if you've used HipChat, it's really cool because we don't email inside the team. Like this is just like how we all like share everything. So this is like Plotly, and so I can like, this is where, you know, like every day we like check in like this, and you can like, you know, load all kinds of stuff in here, and like we deploy from here. So you can like, because we just do like, we still push like 5 times a day, and we just use like automated testing. So we use Circle CI, and so you kind of like you can just push right from HipChat. So we have a bot, and you're like, bot, deploy to prod, or like deploy to stage, and then like Circle CI runs, like checks. It's like an 8-minute test, sees if anything is breaking. You get a +1 from someone else on the team, because we just use GitHub. So like I'll make a pull request on the master branch, and then it'll like test for me, and then I get a +1 from someone else on the team that I deploy. And so that's been cool, because it's let us still kind of like keep pushing pretty fast, rather than having to like, you know, do these like 2, 3, 4 week things of like waiting to see whether it's gonna break when I push or something like that.
Are you guys all deployed in Amazon and that kind of stuff? And
Yeah,
are you
we use
running
Amazon.
containers inside there, or are you guys running containers in there?
Yeah.
Okay.
Yeah, Amazon has been awesome. It's really helpful.
My
Yeah.
company is too, so I'm gonna want to harass you afterwards, because I have all kinds of like deployment concerns in my job too, and it's some of them get pretty fun.
Yeah, we've got this guy named Jody who you should
I'd love to. Like seriously, I'd love to. That'd be really
Would.
cool.
It'd be a good.
He's the miracle weaver. We can, yeah.
Have you heard of this R library called ggpairs? I think it's built on top of ggplot.
No.
So it's dependent on ggplot, and basically, so the standard syntax in ggplot, right, is you specify a single column in your data frame,
Yeah.
another column, and just like does something, right?
Yep.
But then let's say you want to, so let's say the goal is scatter plots, right? Like comparing one column versus another. But then if you have multiple columns and you want to do a pairwise comparison of all these different columns, then you have to do a bunch of reshapes and all that sort of stuff,
Yeah,
which
yeah.
is kind of a pain.
Yeah.
Um,
I love facet wrap though. I've recently gotten into facets.
yeah, well, that's the ggplot.
Yeah.
But in that case, you still have to reshape, right?
Yeah,
you
for
still
sure.
have, which is fine.
Yeah.
But then what's cool about ggpairs, I think ggpairs under the hood basically does that.
Yeah.
Right. But in addition, what it does is it computes various statistics,
Okay.
like correlations and,
Oh,
and
cool.
that sort of thing, and so you know it's been pretty nice for me. So I'm curious if I think I tried seeing if it works on Plotly and it doesn't work.
Yeah.
Obviously. But so if somebody adds something to it and calls it ggplot 3 or
Yeah.
whatever, right? What would they have to do, or is there some sort of is it possible to somehow integrate it easily with existing code that's in
Yeah.
Plotly? No.
Yeah, so we actually we're like our API, our API
Yeah.
is just on GitHub. So a lot of like the stuff that people have like fixed, or we do the same, like all of our APIs and figure converters for converting all this stuff to JSON and like into Plotly is just on GitHub. So if you want to make a pull request we welcome that kind of stuff, you know, and like if you want to talk to us or like, you know, if you want to work on anything, we're happy to. We're part of this cool project called Our Open Side, if you've heard of it. This guy Karthik and Scott run it. So we, you know, they love working with other people, we love working with other people. So if there's something that you find that's not there, you know, like we do issue-based development. So, you know, we get like 50 or 100 emails a day. So we have over 100,000 users now. And so we get just tons of people who are like, I want to do this thing and this thing and this thing. And so once enough people complain about something, that's when we work on it. So that's kind of, and like people have done some pretty cool stuff. I was actually going to pull up this example someone did this pretty cool example of, cause so like pandas is it's like this library package in Python that's kind of like extends some of the functions that a lot of you as R users are probably pretty used to of the concept of a data frame into Python. And so this guy today sent me this notebook that he built that's a converter from pandas to Plotly. And so I hope that he will make a pull request on our API. And so it's cool because so he's just running, he just sets up a pandas data frame here. This syntax probably even looks pretty familiar if you're an R user. And then calls iplot, and it's a one-liner.
That's awesome.
And he just like built his own custom wrapper that's a connector between pandas data frames and Plotly. And so this is like, this is the whole, like this is it. Data frame here, iPlot, and he even made his own themes. He made 3 Plotly themes. Really cool. So this has kind of been like one of the fun things and the advantages for us of like putting as much as we can on GitHub. Is people do stuff like that all the time, you know, and like a lot of our open source projects, or especially around like Arduinos and Raspberry Pis, like that's a super active open source community. So it's cool because like people, like a lot of our stuff in there and some of the devices that we cover streaming from have come from people doing stuff like that. So we'd absolutely welcome that. Yeah.
I'm still trying to take all this in. Am I getting the right impression that the reason that Plotly knows how to draw these plots is because it has explicit code that knows how to draw each of these plots? And when you say you're converting from, say, ggplot to Plotly, it's because Plotly already has a model for the kinds of plots that are going to come from that source? Is that the idea? Or is there some other kind of magic where you can just sort of throw anything at it and somehow it figures out how to draw that thing?
So there are basically 2 ways of plotting from a given language. One is from, because like this has been like what, so we have like our ggplot figure converter and some things in there, and this has been the same challenge that we've had with MATLAB and with Matplotlib, is we don't cover, it's not like we cover the whole like, you know, enclave of different like specifications for where you can do things like annotations, or, you know, because it's like, some of the stuff just sort of gets obfuscated when the plot gets drawn and things are happening on the back end that we can't see because it's not, you know, like it's not all like necessarily out there what's happening. So you can use those figure converters, but we actually have like our own R API that you can just kind of like make lists with. So if you want to throw something at it that we don't cover, you can do that. So for example, we don't support maps. We don't natively support maps, but you can treat like lat long data and like different objects and like build a graph basically. That's not a map. Oh no, I must have overwritten that. But yeah, so like for example, we don't support maps, right? But this is like basically a map because it's using lat long data. So this is a bubble chart drawn on top of a line chart. And so the line chart is lat long data that shows lat long data for Canada, as you can see. And then the bubble charts, and this was made with the maps package in R. So the bubbles themselves are sized for the population size of each city. So we can like zoom in, it gets redrawn, we can keep going, keep going, keep going. And so that is drawn. So we don't, it's the same thing here where there's like this is a similar example too, where this is a line chart that was drawn with a contour map drawn on top of it.
Okay, so basically there are a catalog of plot types that your software knows how to draw,
Yep.
and each of those presumably prescribes what sort of input data it wants. Some sort of input data.
JSON objects, or you can plot from data frames.
Right. Okay, but JSON objects, given you need a JSON object with a particular internal structure in order for it to make sense to that kind of a plot, right?
Once you've declared the plot type, I mean, what do you have an example in mind of something that you're?
Well, I mean, it wouldn't make sense to provide X, Y, and Z data for just a two-dimensional scatter plot.
Yes.
Right. So for each of your known plot types, there's also a specification for the input data structure that happens to be JSON format, but it's nonetheless a structure to it that you need for that kind of a plot.
Yeah. So you'll kind of you'll make a trace and say what data you want to go in, basically. Does that answer your question?
Yeah, more or less. So, well, I guess the follow-up question is, if there's a plot type that you don't support, is there a mechanism to supply some code to make that happen?
Yeah, I mean, this is an all example of that, of like, you can kind of like figure out how to get around it, and we're happy to help if you want, but like, cause we don't support maps, but people have figured out how to make them. Like the first time we saw a bubble chart come through as a map, we were like, hey, how'd you do that? And like people have done network visualization calculations from Julia, and we don't support network visualizations, but people have done them. People have done like protein structures, all kinds of wild stuff that we don't natively support as a plot type.
But your workaround, or let's say platform support for supporting that, is that you can just draw in generic X, Y, move to line to kind of idea. And
Yeah.
can you do that? You can do that in 2D, but can you do it in 3D? Like, can you basically produce a GL type thing that appears in a box?
Yeah, you can do lots of crazy stuff with 3D. We have found.
Emergent behavior.
I hope I don't run across one of those.
Yeah, like this is we don't natively support ice cream cones as a plot type, but this is an ice cream cone that a guy in our team made with MATLAB. So you can kind of like figure out lots of different ways to draw to like orient your data to an axis.
When you say he made it with MATLAB, so how did it get into Plotly?
Fig to Plotly. So set up the graph with MATLAB and then threw it in.
Okay, but what does Fig to Plotly do?
It's the same thing as PyGGPlotly for ggplot2, where it was a MATLAB. Well, some of it was edited natively with our own MATLAB.
I guess what I'm trying to get at is it simply sending like XYZ point data of how to draw the graphic?
Can you flip to the data tab on this thing?
Yeah. It won't. It doesn't accurately represent how the data came in, because we just redrew it as a series of traces. But you can figure out the code to reproduce it here. So the actual code to make this one was a little different than this, but the plot itself came in and looked like this. If you have a specific example, let's talk afterwards.
Yeah, sure. Okay.
Yeah.
So, clarified, coming from ggplot, you are importing essentially ggplot code and the data frame or data objects. You're not translating a grid object.
No. So we
Okay.
take, yeah.
So I can't throw everything else together in grid graphics and pull it across as a grid object.
No, I mean, you could, if you want to plot directly from data frames, you can just use our own R API. The other thing that we're working on now is a kind of like generic data API, because like, sometimes, because we can get up to like, we use SVG to draw our graphs, so eventually the DOM will fill up, but we are working on this data API where you'll just be able to throw in like massive files and just kind of like refer to them.
For the most part, what you're pulling from R, MATLAB, whatever, are static plots that you're then providing the interactive part. So
Yeah.
there's no way to pull stuff from GGViz, the brush paint spin, the tours, and those kind of visualization concepts
I haven't
natively
used
coded
GGViz.
there and pull into you, that at some point that stuff we would be doing natively in Plotly.
We we haven't used GGViz.
Or GViz, which is the die cook.
Yeah. So we don't have like converters for that.
Okay.
The thing that we're working on now is kind of like of what you're talking about is like having brushing and like all of that
And
kind of
linked
stuff.
graphs essentially.
Yeah, so of like being able to do like a lot of that kind of stuff is like the next project for us of like being able to do like toggles and like sliders, and this kind of stuff. So this is this like fractal, and so we're just gonna start shipping, like you'll be able to have like a certain set of specifications that will just like be built in as brushing for like and sliders for any given plot, and then you'll be able to specify some more stuff on top of it. But that'll probably be in the next like month or two. Yes.
So you make the analogy that it's like GitHub for the plots, but like how far does that go in terms of the tracking of what's been done as you're collaborating? Like how much can you step back when somebody or when you yourself overwrite stuff? Like how easy is that to manage, or is it just that it's the collaboration part, but it doesn't really have the tracking of everything that's.
Yeah, we haven't started doing Git style versioning yet, and that's kind of another thing where it's just been like we do, like issue and request driven development, and like a surprising number of people, are just like they want the plot, and it's like because like being able to do like callbacks or like diffs on plots is a little. Yeah, it's a rare use case in comparison to how frequently you need to do that if you're coding. So we will have like Git style versioning at some point.
In the meantime, would you just like have that code archived somewhere?
Yeah, I just also just like sometimes if I like want to work, if I like want to, I'll just like fork a different copy and just like copy my plot. If I know that I want to like play around with it for a while, and there's a good chance I might break it. Or I just like pull out like what I've been doing with this like post that I'm working on is I just have like a big IPython notebook, and like once I've gotten to like a point where I'm satisfied with everything, I like to get like all the Python code in one place and like play with it from there. But we will, we want to have like Git style versioning. The other thing is I think so. There's this guy on our team who's had this really cool project where he's building like an extras tab. So where we have like plot data code right now, there's just going to be an extras tab, and you'll just be able to add files in there. So you want to add like your code or your original data file.
Stuff that should be archived with the plot.
Exactly, yeah, because like plots aren't just plots, right? It's like you have like code that led to it, you have like the original data sets, and you don't you rarely plot the data that you started with in its original form, but you definitely want to be able to have that history with it. So that's kind of like that's another ongoing project. So we're 15 months old, so everything that we've built until now has basically just been like an exclusive focus on the like graphing output themselves. And now we're kind of like, now that we have that up and like people like are using and stuff, now it's like it's really nice because like we can see, or like people will tell us like this is what I need to like really like get this into my workflow appropriately.
Do you have any, just like your ice cream example, you mentioned the network examples, do you have any examples of people misusing Plotly to do network visualizations? That's the place we've had to move to D3, because you can't do it.
Yeah, some guy did some pretty cool ones with Python recently. This is like, this guy did this post with Julia, and it was the first time I'd seen it, where he made a set of network visualizations, and I've seen some guy did an IPython notebook at some point where he did some stuff like that. He was doing it for like protein structures. It was pretty cool. But yeah, I can give you my email afterwards. Oh, also I have T-shirts here too that I'm happy to give out.
Nice.
Yeah, I got like 10 or 15 T-shirts. American Apparel Tri-Blend. But yeah, I can try and dig up some examples for you.
So, but the way they're doing that is like like manually building
It's like
like
points,
a Python
lines.
visualization that you're translating instead of like D3 has some great
Yeah.
tools. But
Oh, yeah, it's awesome, yeah.
okay.
Yeah, it's the same thing. I think the next plot types that we plan to add are going to be maps, and then we'll see from there. But yeah, I think like for doing like network visualization, this stuff is like you can see here where it's just like he did like line chart and scatter chart, and then you can like kind of like calculate thickness for lines. You know,
Yeah, he's iterating.
yeah. I mean, it's a project for sure. Did you have a question?
Yeah, I'm curious on the like a workflow within a enterprise.
Go on.
So like, Department A uses R, and Department B uses Python,
Yeah.
and they're collaborating and using Plotly. How?
Yeah.
I mean, is that your wheelhouse?
Yeah.
So, what's the fidelity that they're going to see? Are they going to get frustrated that this little tiny thing is not quite exactly the same that one's seeing as the other's seeing? Or?
Well, I mean, so the end output, everyone's going to see the same plot, and you can always edit the whole figure object. So the way that we've kind of like set up different ways of interacting with plots is making it so like, if you made a plot with R, I can go in and overwrite parts of it, or I can extend traces that are inside of it, or I can just add a new trace right onto it. So I can like just specify like, oh, I want to drop this new trace onto like your plot that you made with R. I can just do that with Python. And so that's kind of been like, or with MATLAB, or I can just like upload, because you can do that from within the GUI too, where if I have a plot from inside the GUI, I can just say, like first I can just be like, you can just kind of like plot, this is going to be a weird plot, but like, because this is data that originally came from that Anscombe graph right here, and so I'll like make a histogram of it, and then if you want to, you could draw data onto that plot from Python or R, or for any given plot that I have, you can just insert right onto it from like inside of here, where I want to like now draw a new histogram on top of that. So you can just like drop data on top of any plots, or call the figure, the whole figure, and edit the figure itself locally, and then push back into the plot. Does that answer your question?
I think so. I guess I need to see it do it myself on something really complex and like that ice cream plot or something.
Yeah, and a lot of people.
Maybe I'm just overcomplicating it.
We do that a lot inside the company for fun too, because it's like because we have like people who are like exceptional, have like come from like XYZ language background, because it's like we have like Chuck who like builds the MATLAB API, and we have like someone who works like basically full time on R and basically full time on Python, and so it's a lot of times inside the company we're doing that kind of stuff where we're just editing different plots, and it's cool because like we learn a lot about different languages, and like because we're like a very like by nature of the company like we don't really like have strong views on like languages, we're all just kind of like utilitarians, and like it always makes me laugh whenever I read these like which is better, like this like blah blah blah, oh I hate this language, only fools use it, and it's just like it's kind of like a silly argument because it's like use whatever works, right? So that's kind of like how we feel about things, and it's like how a lot of teams feel about things. But yeah, check it out, let us know what you think. We have a ton of like documentation of that kind of stuff too. Yes.
Just wondering, is there the ability to control who has access to a data set that I upload in the free version, or is that only in the enterprise?
Nope, that's here too. So this is a data set of like 2,500 movies. It's like some of the highest grossing movies ever. And it's a log axis here. So we can see, so there's, like 114 movies in the 5 million bucket, 430 here, 15 million, et cetera, and so I can see all of the data here pretty nicely because it's a log axis, and then all the way out here we have Avatar. And but all of that data, so all 2,000 of those movies are represented in this inset plot here. So every single movie from there is right here. And it's so that's also a log axis. So that's a log y axis, and I can actually zoom right here, and it'll take a little while, but so I can just keep going in right here, and so this is, you know, that each time I zoom in, right, it's just like bringing me, and you can even see the axis is adjusting here as I go in. And you could set this up as subplots too if you wanted to. So like notice we're getting almost now you can see the actual individual points, and now I can actually see point by point. So you could save that zoom.
Yeah, that's what I'm talking
And I could just save that zoom and be like, man, isn't it crazy that Pineapple Express made XYZ amount of money? But you want to be able to see that in comparison to the movies that made the most money, and in addition to an overall binning for the histograms. So then you can share it, and you can put, you know, you can put as many subplots in there as you want to, and show it kind of like that. Does that answer it for you?
Yeah.
Cool. Other questions? I thought I saw someone raise their hand in the back. Cool. Well, thanks for coming out. I have some t-shirts if you want to come get them. I'll hang out afterwards if people want to chat. And we welcome pull requests on GitHub. Thanks, guys.